在区间 I 上能够保续 preserves order， 所以就递增。Similarly for statement 2. If a real number which is negative, again, if we consider x1 and x2 any in this interval I, by mean value theorem, xy is less than x2. So x2 minus xy is positive. Positive. But this number now is negative. Positive to negative means that this one is smaller. This one is smaller. Whenever xy is less than x2, f of x1 is, sorry. x1 is smaller than x2, but f of x1 is greater than f of x2, also reverses the order. So this function is decreasing. Number 3, if f parentheses is 0, then these two numbers are the same. So in this case, we may fix any number, consider any number x0 in this interval, and any other, okay. If this is 0 means f x1 equals f x2 for any two numbers. So if we fix one of them, we say this is x1 anyway. Regard this as x1, this is x2, then the value here will be the same as this one. If we consider another position here, regard this as x1, this as x2, these two values are the same. So anyway, C is the value of this given point. Okay. So this is constant on I. 第三个，如果在一个区间 I 上连续内部又可是导数在里面通通是零，保证它是一个 constant， 这是 constant 常数的意思。为什么呢？因为一样任意给2点，这导数是0了嘛，代表说这个是0嘛，这永远相等，任意取的都相等。那我们现在任意取一个点固定。好，如果x 比它大，就把这个当成刚才的 x1， 这个当成刚才的 x2， 这个函数只要一样。好，如果取2点，另外一点跟它不一样，比它小，就把这个当成 x1， 这个当成 x2， 两个值要一样。所以不管 x 比它大还是比它小的值，通通跟它一样，就是变成常数了啊，可以吗？ So all the results can be read from this equation. Okay, so this, as you can see, this is one of the reasons why mean value theorem is so important, because it connects order, differentiability, also continuity. Differentiability implies continuity. Good. So not only from the moving particle viewpoint or from mean value theorem, mathematics. This result is called increasing decreasing test or monotonicity test. 递增递减检验法，或者是单调检验，就是判别什么时候递增，判别什么时候递减。Usually, we can memorize this describe this theorem by this table. If this is positive, then increasing. Negative, then decreasing. Increasing, decreasing. Okay. Use increasing, decreasing test. We can form a test called first derivative test. First derivative test. The first derivative test what? Just now, test the monotonicity, but now test the local maximum or minimum. test. Test of what? Test local maxima or local minimum, local extrema. Okay. This test is an application of the monotonicity test or decreasing test. Let me explain why. For the first statement, okay. Now C is a critical number of C, means if f is differentiable at C, then f prime C is 0 by definition. Maybe f is not differentiable at C. Anyway, for statement A, if we explain this by a table, C is a critical number. F is continuous at C. Okay, if at C f is differentiable, then this is 0. Maybe at C f prime does not exist. Quite possible. Well, statement A, the sign of f prime changes from positive to negative at C. From positive to negative means when x from the left to the right at C. From the positive to negative, okay, decreasing, and continues at C, a critical number, so f of C is local maximum, increasing and decreasing, right? For B, f prime changes from negative to positive, means the sign f prime, the符号 sign of f prime changes from negative to positive at C, means from negative to positive at C, decreasing. Oh, yes, use the decreasing test. When f prime is positive, then on this interval, relative interval, increasing. So in this case, we know decreasing then increasing. Or maybe non-differentiable. Anyway, f of C is a relative minimum, right? Finally, at C, positive to the left and to the right. Increasing and increasing. So in this case, the graph of this function maybe looks like this. So f of C cannot be a relative minimum because on any interval, values at numbers left to C will be less than f of C. So f of C cannot be a relative minimum. Similarly, f of C cannot be a relative maximum because all values at points or numbers right to C will be greater than f of C. Finally, f prime is negative to the left and the right at C. may be non-differentiable. Negative to the left and then to the right at C. Negative to the left and then to the right at C. Decreasing and decreasing. Maybe. Therefore, FC cannot be a local minimum or a local maximum. Okay, take a break. Thanks.